in this class, we're going to go over questions on pedology and soil physics. Okay, let's take down the question. A sample of moist soil with a wet mass of 1.0 kilogram and a volume of 0.64 liters was dried in the oven and found to have a dry mass of 0.8 kilogram. Assuming the typical value of the particle density for a mineral soil is 2,650 kg per meter cube, calculate the following with the appropriate units: the bulk density, the porosity, the void ratio, the gravimetric water content, and the volumetric water content. Okay, let's start by writing out the information that we're given in the question. Okay. Please kindly pay attention. We are given that a sample of moist soil with a wet mass of 1.0 kilogram. That means the wet mass is 1.0 kilogram. You understand? And a volume of 0.64 liters. Now, we are given the volume in liters and also a meter cube. You understand? But the type of volume that we need in this question is a meter cube. You understand? So the volume equals to 0.64 liters, and that will be 6.4 times 10 raised to the power of negative 4 meter cube. You understand? This is what we need. You understand? Okay, so we are given the volume as this. Now, when this soil was oven dry, you understand? When you dry something, you are removing water. Are you paying attention? So, when this soil is oven dry, the weight of the soil is reduced to 0.8 kilograms. So, that is dry mass. Okay? The dry mass of the soil equals to 0.8 kilogram. Do you understand? Okay? Now, we are given that the particle density for a mineral soil is 2,650 kilogram per meter cube. The particle density, let us call it, okay, particle density equals to 2,650 kilogram per meter cube. Okay. Now we have to calculate the bulk density. Now, before we calculate the bulk density, I'm very sure you are part of our previous class. Don't forget that I told you bulk density refers to the mass of the soil per unit volume. Are you paying attention? So bulk density, let me represent as BD. Bulk density equals to the mass of the soil all over the total volume. You understand? Now, the mass of the soil must be in gram. Are you paying attention? And the total volume must be in what? Centimeter cube. Do you understand? The mass of the soil must be in gram and the total volume must be in centimeter cube. Now, looking at the parameters that were given in the question, the mass of the soil was given in kilogram. Are you paying attention? And the volume of the soil was given in meter cube. You understand? Now, we have to do conversion. Are you paying attention? Now, in our previous class, I told you that to convert 1 kilogram to convert gram and kilogram to gram, we have to multiply that kilogram by 1,000. You understand? Because from the basic unit measurement, 1,000 gram equals to what? 1 kilogram. Do you understand? So to convert 1 kilogram to gram, we just have to multiply 1.0 kilogram by 1,000. Do you understand? So let us quickly do the conversion in this place. We're going to have the wet mass in gram will now be 1 multiplied by 1,000. That will be what? 1,000 gram. You understand? So the wet mass is in gram. Now let us convert the dry mass as well. The dry mass of the soil, please, are you paying attention? The dry mass of the soil will be 0.8 also multiplied by 1,000. Do you understand? You see, what I'm doing is that I'm changing the unit from kilogram to gram. You understand? Because the bulk density should be calculated in gram per centimeter cube. You understand? Okay. So this I'm going to have 0.8 multiplied by 1,000. Okay. That will be what? 800 gram. Do you understand? Okay. Now let us convert the volume also to centimeter cube. Do you understand? The volume in centimeter cube can. Don't forget, for your basic unit measurement, how many centimeter cube make 1 meter cube? Now, let me quickly do something. You know that 10 millimeter equals to 1 centimeter, okay? 10 centimeter equals to 1 decimeter, you understand? 10 decimeter equals to 1 meter. Now, How many centimeter will be equals to 1 meter? That will be what? 100. Because by the time you move from this place to this place, I'm going to have 10 times 10. That is what? 100. That means that 100 centimeter equals to what? 1 meter. 100 centimeter equals to 1 meter. Now, we are going to raise this to 3. Raise this to 3 and raise this to 3. Because we are dealing with centimeter. We need the volume in centimeter cube. The reason why I'm doing this is because, peradventure, if you didn't remember your unit measurements, you understand, all you have to do is to just remember the basic one. You understand? By the time I knew that 100 centimeter equals to 1 meter. So if I cube it, if I raise it to the power of 3, I'm going to get the value in meter cube. You understand? So that's it. Now this will give me 100 centimeter times 100 centimeter times 100 centimeter. You understand? That will be what? Equals to 1 meter times 1 meter times 1 meter. You understand? Okay, 100 times 100 times 100. That will be what? 1 million. That is 1 million. Yes, 1 million centimeter cube will be equals to 1 meter cube. Do you understand? Okay, 1 million centimeter cube equals to 1 meter cube. Now, don't forget, we are giving the volume as what? 6.4 times 10 raised to the power negative 4 meter cube. Now, from your standard form, 6.4 times 10 raised to the power of negative 4 meter cube. I want to change it. This is in standard form now. I want to change it to decimal. Are you paying attention? Now, this will be 0.00064. That meter cube. You understand? 1, 2, 3, 4. Oh no, 0.0. It is 3 0. 0, 0, 0. You understand? 1, 2, 3, 4. Okay. So when I change this from standard form to decimal, I have 0.00064 meter cube. Now, since I know that 1 million centimeter cube equals to 1 meter cube, let x equals to what? 0.00064 meter cube. You understand? Here I'm going to cross multiply. Hence I'm going to have x multiplied by 1 meter cube equals to 1 million. 1 million can be written as 1 times 10 raised to the power of 6. You understand? Multiplied by this will be given 0.00064 meter cube. You understand? The reason why I changed this to standard form is because I want to minimize the space. You understand? So divide both by 1 meter cube. 1 meter cube. You understand? This will cancel this. So I'm going to have x equals to this meter cube. You cancel this meter cube. So don't forget that 1 million is what? 1 times 10 raised to the power of 6. You understand? And you know that it is 1 million centimeter cube. You understand? The unit is in centimeter cube. Let me put it here. The unit is in centimeter cube. So 1 million centimeter cube multiplied by 0.0064. We're going to have 640 centimeter cube. Do you understand? So the total volume in centimeter cube, the volume. Okay, let's just put it here. The volume in centimeter cube equals to 640 centimeter cube. You understand? And the wet mass in kilogram, in gram rather, is what? 1,000 gram. You understand? And the dry mass, please, are you paying attention? The dry mass in gram equals to what? 800 gram. You understand? Okay. So now, having convert the unit, I can proceed to calculate the bulk density. You understand? So we are going to calculate the bulk density now. Let me erase this. You see, the reason why I go this long way is because I want you to understand. If I'm doing this in exam, all I have to do is that I have to multiply this volume by 1 million centimeter cube. I'm going to get it. I'm going to get the volume in centimeter cube. You understand? I'm just going to multiply this by 1 million. Okay. So if you are doing this in exam for you to be fast, just have it at the back of your mind that 1 million centimeter cube equals to 1 meter cube. Do you understand? Okay. Now, the bulk density will be equals to the mass of the soil in gram. The mass of the soil in gram is the dry mass. You understand? The mass of the soil in gram is the dry mass. The dry mass is what? 800 grams. So I'm going to have 800 gram all over the volume, the total volume. The total volume is what? 640 grams. So I'm going to have 640 centimeter cube. Okay, 640 centimeter cube. Here I'm going to have 800 gram divided by 640 centimeter cube. That will give us 1.25 gram per centimeter cube. Okay, 1.25 gram per cm cube. Do you understand? Okay, that is the first question. Now the next question says we should calculate the we are asked to calculate the porosity. Now, in our previous class, I explained what is meant by porosity. Porosity refers to the spaces in the soil that is filled with air and water. You understand? So, to calculate the porosity, we are going to use this formula: 1 minus bulk density over particle density. You understand? Porosity, just pay attention, okay? Porosity equals to 1 minus bulk density all over particle density. You understand? Okay, if you are in our previous class, you should be able to solve this, but there is something that I want you to know. You know that the particle density that we are given is what? Is in kilogram per meter cube. We have to change it to gram per centimeter cube. You understand? Just listen, you are going to understand. Okay, you know that in our previous class, the particle density that we are given is in gram per centimeter cube, so we use it directly. But in this video, in these questions, the particle density that we're given is in what? Kilogram per meter cube. So I have to change the particle density from kilogram per meter cube to gram per centimeter cube. You understand? Now, how do we do that? It is very simple. Now, I want you to pay attention. Let us convert the particle density from kilogram per meter cube to gram per centimeter cube. 1000. Now, I want you to pay attention. Do you understand? Let us convert the particle density from kilogram per meter cube to gram per centimeter cube. Okay? 1 gram per centimeter cube equals to 1000 kilogram per meter cube. You have to note this unit. Are you paying attention? 1 gram per centimeter cube equals to 1000 kilogram per centimeter per meter cube. Okay? Now, that means that we are going to represent x equals to 2650 kilogram per meter cube. 2650 kilogram per meter cube. Okay? For this, we are going to cross multiply. You understand? So I'm going to have x multiplied by 1000 kilogram per meter cube equals to 1 gram per cm cube equals to multiplied by 2650 kilogram per meter cube. The next step here is that we are going to divide both sides by what? 1000 kilogram per meter cube. You understand? This over 1000 kilogram per meter cube. Do you understand? Now, this will cancel this. So I'm going to have x equals to, please pay attention, this kilogram per meter cube will cancel this kilogram per meter cube. You understand? So I'm going to have 1000 gram per centimeter cube multiplied by 2650. That will give us 2650 gram per cm cube all over 1000. You understand? Hence, x will be equals to 2.65 gram per cm cube. I just showed you this long process so that you will know that anytime you are given 2650 kilogram per meter cube as your particle density, you have to change it to gram per centimeter cube. Do you understand? So we are not going to use 2650 kilogram per centimeter per meter cube directly. If you use that, you are not going to get the right answer. Okay? So the particle density in centimeter cube in gram per centimeter cube is what? 2.65 gram per cm cube. You understand? Okay, so let me erase this so that we can calculate the porosity. Okay, now the porosity is equals to 1 minus bulk density. The bulk density is what? 1.25. So I'm going to have 1.25 gram per cm cube all over the particle density. The particle density is 2.65 gram per centimeter cube. You understand? So for this, I'm going to have 1 minus, if you point your calculator, 1.2, okay, let me pose the bracket. 1.25 gram per centimeter cube divided by 2.65. That is 0.4717. 1 minus 0.4717. So here I'm going to have 1 minus 0.4717. That is 0.5283. 0.5283. So the porosity in percentage, we're going to multiply it by 100. So I'm going to have 0.5283 multiplied by 100. Here I'm going to have 52.83%. You understand? That is the porosity in percentage. Now let us calculate the void space. Okay, the void ratio. Sorry, the void ratio. The void ratio. Now, what do you mean by void? Void means an empty space. An empty space within the soil, including the pore space and the space that is not occupied by any solid substances within the soil. That is what we call the void space. You understand? All this I explained in a previous class. Okay, now how do we determine the void ratio? Void ratio is given by this formula: volume of the void all over the volume of the solid. This is the formula for calculating void ratio. You understand? Now please, I want you to pay attention. In our previous class, we did void space. We are asked to calculate void space. You understand? Now we are asked to calculate void ratio. What is the difference between void ratio and void space? I'm going to explain, okay? With respect to this question, you can make use of the formula that we use to calculate the void space, to determine the void ratio. Are you paying attention? But there are some cases whereby you are going to be given the specific gravity. You understand? In the question, we haven't given the specific gravity, we are only given the particle density. You understand? So we can make use of the formula that we use to calculate the void space to determine the void ratio in this case. But there are some cases whereby you are going to be given the specific gravity. Are you paying attention? So in our previous class, we used this formula to determine the void space. The particle density all over the bulk density minus 1. This is the formula that we use to determine the void space. But now, we are asked to calculate the void ratio. The void ratio is given by this formula: the volume of the void all over the volume of the soil. You understand? Or the volume of the solid. You understand? The volume of the solid, please pay attention. The volume of the solid is equals to this mass of the soil all over the specific gravity multiplied by the density of water. You understand? This is the formula for calculating the volume of the solid. Now, how do we determine the volume of the void? The volume of the void, please pay attention. The volume of the void is equals to the total volume minus the volume of the solid. You understand? So don't worry. I'm going to do more class on this particular one, void ratio. Are you paying attention? I'm going to teach you how to use this formula. But here, we are going to make use of this formula. We are going to use this formula to determine the void ratio. You understand? Now, so the void ratio, please pay attention. The void ratio equals to the particle density. The particle density is what? 2.65. 2.65 all over the bulk density. The bulk density is what? 1.25 gram per centimeter cube. 1.25 minus 1. You understand? Here I'm going to have the void ratio equals to 2.65 divided by 1.25. That is 2.12. Okay? 2.12 minus 1. You understand? So the void ratio equals to 1.12. Now we can change this to percentage. Are you paying attention? This is the void ratio. Now we are going to change it to percentage by multiplying it by 100. You understand? So I'm going to have the void ratio in percentage. The void ratio in percentage equals to 1.12 multiplied by 100 equals to what? 112%. You understand? So this is the solution to that question. Now we have calculated the bulk density, the porosity, and the void ratio. Question 4. We are asked to calculate the gravimetric water content. Now in our previous class, I let you know that the gravimetric water content or moisture content is also the same thing as calculating the moisture content on mass basis. You understand? Please pay attention and listen to the explanation again. Okay? The gravimetric moisture water content is also the same thing as calculating the moisture content on mass basis, because in the previous class that's what we are told. We are asked to calculate the moisture content on mass basis in percentage and on volume basis in percentage. Now we are asked to calculate the gravimetric water content. Don't be confused, you understand? It's also the same thing. So that is question 4. We are asked to calculate the gravimetric water content. The gravimetric water content, gravimetric water content this is the formula that you're going to use to calculate the gravimetric water content. It is given by mass of the water all over the mass of the soil multiplied by 100. Do you understand? Mass of the water, gravimetric water content equals to mass of the water all over the mass of the soil multiplied by 100. You understand? Because we must put it in percentage. Okay, so the mass of the water, how do we determine the mass of the water? The mass of the water is the difference between the wet mass and the dry mass. You understand? The mass of the water is the difference between the wet mass and the dry mass. Don't forget that the wet mass composed of two things, the soil and the mass. Hello? Why we call it wet mass is because this soil contains soil and water. You understand? That is what we call it wet mass. Now, when the soil is even dry, the water content was removed. So, in an attempt to calculate the mass of water, that is the water content that is removed, we have to take the difference between the wet mass and the dry mass. You understand? So, for this, I'm going to have the mass of water will be the wet mass, okay, wet mass minus dry mass all over the mass of the soil multiplied by 100. You understand? So the wet mass is what? 1000 gram minus the dry mass, which is 800 gram, all over the mass of the soil, which is 800 gram, multiplied by 100. You understand? If you understand, listen to the explanation again, okay? The difference between these, I'm going to get the mass of the water in gram. You understand? Okay? 1000 gram minus 800 gram, that is what? 200 gram all over 800 gram multiplied by 100. Now listen to this explanation. The dry mass is not the same thing as the mass of the soil. You understand? The mass of the soil is the soil mass alone. That mass, when the water content has been removed, that is the mass of the soil. You understand? And that is why I'm having 200 gram all over 800 gram. So that you won't be thinking that the dry mass is also the same. Yes, the dry mass is also the same thing as the mass of the soil. Okay? So now, if you take the division of 200 gram and 800 gram, you're going to have 1 all over, that is 1 over 4. Okay? 1 over 4 multiplied by 100. So the gravimetric moisture content DWC equals to 25%. You understand? So that is the gravimetric water content. Now, how do we determine the volumetric water content? Whether they put it as volumetric water content or moisture content, just know that it is the same thing. Okay? Please pay attention. Whether the question says gravimetric moisture content or gravimetric water content, or volumetric moisture content or volumetric water content, it's also the same thing. Okay? Don't get confused. Now, how do we determine the volumetric water content? Okay, to determine the volumetric water content, VWC, is given by this formula: the volume of water all over the total volume. You understand? Now, we know that the total volume is what? 640 centimeter cube. Now, how do we determine the volume of water? To determine the volume of water, we have to make use of the density of water. You understand? That's how we did in our previous class as well. To determine the volume of water, we have to make use of the density of water. The density of water is constant. You understand? The water density equals to 1 gram per centimeter cube. You understand? If you look at this unit, you can see that it is gram per centimeter cube. That means that we divide mass of water by the volume of water. You understand? So, to calculate the volume of water now, I'm going to have 1 gram per cm cube equals to the mass of water all over the volume of water. Are you paying attention? Now, the mass of water is what? 200 gram. Do you remember how we, when we calculate the gravimetric water content, we take the mass of water as this. The mass of water, MW, equals to 100 gram, okay, 1000 gram, sorry, 1000 gram minus 800 gram equals to what? 200 gram. You understand? That is the mass of water. You understand? Okay, so the mass of water is 200. So I'm going to have 1 gram per centimeter cube equals to 200 gram all over the volume of water. Are you paying attention? Here, to get the volume of water, I just have to take the cross product, and so I'm going to have the volume of water equals to, okay, I don't want to skip any step. Okay, let's go. I don't want to skip any step. Now, volume of water multiplied by 1 gram per centimeter cube. I'm going to have volume of water multiplied by 1 gram per cm cube equals to 200 gram multiplied by 1. That is 200 gram. Okay, divide both sides by what? 1 gram per cm cube. This over 1 gram per cm cube. I'm going to have this to cancel this. So I'm going to have the volume of water equals to what? 200 cm cube. Because this gram will cancel this gram. You understand? Okay, so the volume of water now is what? 200 cm cube all over the total volume. The total volume is what? 640 cm cube. 640 cm cube. You understand? Now, if you 200 cm cube divided by 640 cm cube, that is 0.3125. You understand? That is 0.3125. Now we have to leave the volumetric water content in percentage. So I'm going to have VMC in percentage is equals to 0.3125 multiplied by 100. You understand? That will be what? 31.25%. You understand? So that is the answer to that question. Please, do you understand? If you have any question regarding this, kindly let me know in the comment section. Okay, so I will attend to the question. If you have any question regarding this solution, okay, now that is the solution to that question. If you come across this question in exam, if you solve it like this, you have a mark. Okay, see you in the next class. To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.